Hello dear students, welcome to the sensors and transducer class. In last class we were discussing about the topic say strain gauges, and we have already studied about the working principle, construction, all those things. And in last class we started the signal conditioning circuit of strain gauge, and there we found that the Wheatstone bridge circuit is used for the resistance measurement in strain gauge. So in the last class we told you that the Wheatstone bridge circuit is normally used for the resistance measurement of strain gauge because of two important factors. The first one is that in case of the strain gauge, the resistance change that occurs due to application of stress is very small. So we need a circuit which will be capable to detect such small change in resistance. And Wheatstone bridge, as it works on the principle of the null balance, very small changes in the resistance can be easily detected using the Wheatstone bridge circuit. And the second factor is that as the strain gauges are nothing but simple resistances made up of conducting elements, that is why these resistors are also prone to change in the temperature. So basically, due to change in the ambient temperature also, the resistance of the strain gauge may change. And if due to the change in the temperature the resistance changes, that will also indicate a change in the measuring circuit, and which may be considered, which may be misunderstood by the user as a change in the strain. So that is why we have to use the temperature compensation process. So the Wheatstone bridge also gives us a readily available compensation process for the temperature effect by use of the dummy gauge. So today first we will discuss about the sensitivity of the strain gauge, sensitivity of the Wheatstone bridge circuit, and then about the temperature compensation effect. So while we will discussing about the sensitivity, we consider that the Wheatstone bridge circuit can be of three types, or basically we can use three configuration of the Wheatstone bridge for measurement of the strain gauge resistance. So what are those configurations? They are called quarter bridge, half bridge, and full bridge. Okay, so we will one by one discuss about this different bridge configuration. Okay, so let us do it using, we have to do some derivation. So let us point the camera towards the copy. So first we discuss about the quarter bridge. So what is a quarter bridge? In the Wheatstone bridge we have 4 arms. So among these 4 arms we connect our voltage supply across 2 arms. Let us consider it is A, B, C, D, and among these 2 points we get the output voltage. So say this is our input voltage EI and this is our output voltage EO. Okay, and these are the resistances R1, R2, R3, R4. So among them, say first of all, here in case of the quarter pitch configuration, we consider that among these 4 arms, only one arm is consisting of the strain gauge. So let us consider that this arm R1 is our strain gauge. Okay, so this is called the active gauge. Okay, so only one arm is consisting of the active gauge, and the other arms, they are just simple resistances. Okay, they are standard resistances. So while in the other arms we are using the standard resistances, so we can consider that all these resistances are of equal value. Okay, so we consider that R2 equals to R3 equals to R4 equals to R. Okay, and also we consider that the unstrained resistance of R1 is also R. Okay, now what happens when you apply some strain? So when you are applying some stress to the strain gauge, that is in arm R1, then the resistance of the R1 will be changing. Okay, so let us consider that the change in the resistance due to application of the strain is delta R. So after application of stress, the change in resistance R1 is delta R. So now the resistance, now R1 becomes R plus delta R. So this is the value of the R1 now. Okay, now at this condition our bridge is unbalanced, because initially when all the resistances value were same, at that time our bridge was balanced. Okay, now due to change in the resistance R1, the bridge will become unbalanced. Okay, so at this unbalanced condition, what should be the output EO? So at this condition, the output or the change in the output EO can be considered as del EO, and it will be given by the potential at point B minus potential at point D. Okay, so now consider that what should be the potential at point B and what should be the potential at point D. So at point B it will be, as this is your positive side is connected through this, so in this circuit we can get the potential at point B will be like this, that it is the R plus delta R, this thing divided by the total resistance, that is the R, that is the resistance of R4 plus R plus delta R into that input voltage whatever it was, that is EI. minus what should be the potential at point D? It will be your R2 value is also R divided by R plus R into EI. So we can write it in this way, that it is the R plus delta R divided by 2R plus delta R minus 1 by 2 into EI. So that implies R plus del R minus 2R minus delta R divided by 4R plus 2 delta R into EI. So that equals to 1 minute. That equals to your, it becomes this one cancels, and R minus 2R, that is your R by okay. So over here we get this is 2R plus 2 delta R minus 2R minus delta R. So this 2R and 2R cancels, and this 2 delta R and delta R, from there we get only delta R, and at the denominator we are having 4R plus 2 delta R into EI. So we can write it del R by R divided by 4 plus 2 del R by R into EI. So over here this del R by R, it is the fractional change in the resistance per unit resistance. So this quantity del R by R is very small, so this 2 del R by R is much smaller than 4. For that reason we can write this del R by R divided by 4 into EI. Okay, so now this over here del R by R is, we can write it as the gauge factor. We know that gauge factor is equal to del R by R divided by strain. So del R by R can be substituted as the gauge factor into strain divided by 4 into EI. Now what is the sensitivity? Sensitivity is nothing but the output by input. And in the deflection bridge, what is the output? In the deflection bridge, output is the delta E, that is the deflection in the meter. So this delta EO is your output. So your sensitivity delta EO output by input. Input is what? Input is the strain, by epsilon is equals to gauge factor into EI by 4. Okay, so this becomes the sensitivity of the quarter bridge. Okay, so here we can find that sensitivity is nothing but it is the product of the gauge factor into the gauge factor and the input voltage divided by 4. Okay, so this is the sensitivity of the quarter bridge.